The Astro Buds. We're looking at the Ring Nebula once again, and I am not liking what I'm seeing. You can see the distended stars. I did check the counterweight balances on the scope today. They weren't very far off, so it doesn't account for why we're getting distensions. One thing I will say is I'm looking at we're no longer seeing with this new version of the software printout that says right here whether or not there was triangulation or not. And I do believe I made that upgrade to it just before the last session out, which was the NGC 6600 to 6700 series. What I am seeing down below that you can't see is it says a stack finished, 10-second stack, 12 have been stacked, and none have been ignored. But if they've been stacked, you would think that they would have put one star right on top of the next and the Ring Nebula right on top of itself. And that ain't what's happening. So I'm beginning to suspect in our 7 steps of troubleshooting, recognizing, basically explaining and diagnosing it to yourself, and then going on to list possible problem causes, etc., that there is a problem with the latest release of the ASI Studio software. So I'll have to do some research on tomorrow. But we're not going to waste tonight. Tonight we have to go about our 6700 to 6800 sampler of deep sky studies that are visible to the west. So let us resume that, and I'll pick out our first study. Well, right off the bat, we got an NGC 6700 in Lyra before the stars started distorting. Let's run it up to 150x. 6700 galaxy in Lyra, magnitude 13.1, 1.4 by 1 arc minute. Start with a bar, lowercase c, so 3 times removed from the lenticular, but it has a fairly obvious core. 209 million light years distant, probably about 50,000, 60,000 light years in diameter. Right ascension 1846.04 with a declination of plus 32 degrees, 16 minutes, 47 seconds. I am going to move on before it starts to get ugly. This is our 150x view. Okay, looks like a globular cluster, but it is not. This is NGC 6705. We'll fill the screen here a little bit. Open cluster in Scutum, aka Messier 11. Total magnitude, cumulative 5.8, 14 arc minutes in size, some 500 stars. The brightest are magnitude 8. It's a 1, 2, a Roman numeral 1, and we know what that means. Very distinct from its background. 2 stars of roughly with a nice, decent spread of magnitudes, but not too disparate. 6,100 light years distant. Right ascension 1851.05, declination minus 06, 16, 12 seconds. That's our view of Messier 11, the wild duck cluster. Okay, we have our first stack here of 10 seconds. Galaxy in Lyra, NGC 6710. Let's zoom in on it before we get too far along and the stars start getting distended. Magnitude 13.1, 1.7 by 1 arc minute. Spiral with a lowercase a. Accounts for the bright central core. We're already distorting. 209 million light years distant. Right ascension 1850.34 with a declination of plus 26 degrees, 15 minutes, 16 seconds. Backing out for a better view. I will tell you that I am seeing no ignored stacks. 5 stacks have already occurred. Total exposure time 50 seconds. But we are not seeing what we expect to see when triangulation occurs. The latest version of ASI Studio has got something seriously wrong with it in my estimation. Okay, before things get too distended, this is NGC 6712. I'm waiting for data to come up. Obviously, it's a globular cluster. It's in Scutum, magnitude 8.2, 4.3 arc minutes in size. Brightest stars are magnitude 13.3. It's a class 9, so fairly diffuse, 22,000 light years distant. Right ascension 1853.04, declination minus 8 degrees, 42 minutes, 19 seconds. I won't be zooming anymore because the stars are going to get distorted. Okay, faintest galaxy of the evening, and you can see it right there at the 60x field, is a magnitude 14, NGC 6713. Galaxy in Lyra, 0.4 by 0.3 arc minutes. Wow, we're getting some sense of frontier and a little bit of texture on this one almost. 242 million light years distant. This one's probably about 35,000 light years in diameter. Right ascension 18 hours, 50:44. Declination plus 33, 57:35. Let's do a little more zoomage. Hopefully the stars won't be too distended. Now they are a little bit, but here is our 14th magnitude. Now this could be, it's a lenticular spiral. It may actually be 13th magnitude if they are citing the blue-violet magnitude that you would read off a photographic plate rather than something that's been accumulated over time visually with eyepiece astronomers. I have to say, this has got to be an astounding night in the sky. We're at minus 30 degrees, 28 minutes, 46 seconds for NGC 6715, a globular cluster in Sagittarius. It was seen by Messier, listening to his catalog. Messier 54, magnitude 7.7, 9.1 arc minutes in size with resolvable stars down to magnitude 15.2, although it's got a very thick core. It's a class 3, which means pretty close to a highly condensed globular cluster, but this baby is 85,000 light years distant. So it's essentially, it's probably about 200 light years in diameter. Right ascension 1855.03 with a declination of, as I said, minus 30 degrees, 28 minutes, 46 seconds. I usually wouldn't go there, but I did anyway because it was a messy A. Oop. We're getting some luminosity now on the screen. We're supposed to have another globular cluster. Magnitude 8.4. This doesn't seem to be right, does it? Maybe the scope is mispositioned. Supposed to be right about there. This should be NGC 6717, a globular cluster in Sagittarius. 8.4 magnitude, 3.9 arc minutes in size, magnitude 14 stars. It's a class 8, so fairly diffuse. 23,000 light years distant. Light ascension 1855.06 with a declination of minus 22 degrees, 42 minutes and 5 seconds. I think I'm going to go to the Ring Nebula and make sure it's turning up in the middle of the field. Okay, it's now 8:03. We're not quite, well, I would say we're into sky dark, even though it's only an hour and 10 minutes or so after the sunset. And the Ring Nebula to turn up where we expect it to be. Our IC galaxy is quite present right there, and our MCG galaxy there. So, 10-second exposure before the stars start to look too distorted. Let's back out and go back to another study in the NGC 6700-6800 sampler. Our next study is in fact NGC 6720, which we all recognize as Messier 57, the Ring Nebula. Doing some zoomage here before things get out of hand. Maybe I'll make a few adjustments of the histogram, pushing it over to the right where it gets dark. All right, here we go. And I think the left histogram looks pretty good. Our galaxy should be here and here. But you know what? I think that maybe I should have stayed with the original vision because it seemed to give a better view of the IC galaxy here, and I believe the MCG galaxy is one of these here. I suspect it's this one right here, although there's some things that look an awful lot like a 15th magnitude galaxy. Okay, backing out once again to 60X, we should get some data on this. NGC 6720, planetary nebula Lyra, Messier 57. Its magnitude 9.4, 86 by 62 arc seconds in apparent size. The central star is supposed to vary between 14.9, but this one cites the 15.8 upper value figure, 2,900 light years distant, with a right ascension of 1853.35 and a declination of plus 33 degrees, 1 minute 44 seconds. I think I should point out, and I'm going to have to pause for a second. Okay, I paused it so that we lost some of the distorted stars, but I'd like to point out that we are seeing not only the central star, but another star that abides within, probably line of sight star within the ring, or maybe it's shining through it. Anyway, this one's supposed to be around 15th magnitude. This one I probably think is about 16.5, my estimation. Have to look it up. All right, this one may be rather hard to detect. Run it up a little bit. About 120x, NGC6724, open cluster in Aquila, magnitude 12, 6.2 arc minutes. So I suspect it's this little circularity here. 3,600 light years distant, no data on it. Light ascension 1856.46 with a declination of plus 10 degrees, 25 minutes, 42 seconds. That'll show you this has definitely got to be like a Roman numeral 3, because it certainly doesn't stand out particularly well from its background, its space. All right, this is going to be open cluster 6738 in Aquila, magnitude 8.3. However, it's rated to be blending into the background sky class IV, which is the least able to identify itself from the background sky. And it doesn't make any sense to me if that's the case. 15 arc minutes in size. So this region here, 2,300 light years distance. It's a class 2, which means the stars are not a class 1 where the stars are pretty much the same magnitude, but there's a little disparity in the stars. Right ascension 19 hours, 1 minute, 21 seconds with a declination of plus 11 degrees, 36 minutes, 54 seconds. No zoomage required. Okay, what we should be seeing here is a faint-ish galaxy, and I do believe it's visible right there. And we shouldn't be, because it's magnitude 15, so it's probably the blue-violet magnitude. We're not getting a particularly good background view. The stars are distending once again. I think I'll go ahead and reload it and then give you the data. Here's our 150x view of NGC6740 Galaxy Lyra, magnitude 15. Fairly large for a magnitude 15, apparent size 0.9 by 0.8, spiral with a lowercase b and a ring. So the spiral arms wrap around it. I think that's somewhat apparent here. Typically magnitude 14.5 would show an annularity, but we're seeing one at 15. 200 million light years distance, so it's about 60,000 light years in diameter. Right ascension 19 hours 50 seconds with a declination of plus 28, 46, 15. Backing out once again, let's confirm. Yeah, we are kind of seeing this one in there. Wow, this is a beautiful sprinkling of stars. It's a globular cluster in Aquila. Magnitude 12.4, 6.3 arc minutes in size, so that average surface brightness is quite faint. Brightest stars are magnitude 16.5, and before the field started distorting, we were seeing them at a mere 60x. I'm going to go ahead and reinitialize again. Okay, here's our view once again. Go to 150x. Magnitude 12.4, as I said, 25,000 light years distant. Stars to 16.5 are already getting distorted. 19 hours, 5 minutes, 15 seconds with a declination of 1:54:02. Now, there is a possibility the scope isn't tracking very well, but you know what? It's been centering up pretty good from study to study, so I don't know that this distortion is being caused by the mount tracking at all. I don't like the fact that I got a software upgrade just before all of these anomalies started manifesting. What we're looking for is this planetary nebula, 6751. And you know what? I am almost misremembering the sequence we're supposed to be doing tonight. I think it was 67 to 6800. Anyway, we are clearly making out this planetary nebula. I'm going to push it up to 300x. It's in Aquila, magnitude 12, 20 arc seconds in size with a magnitude 13 central star. 8,400 light years distant, right ascension 19:05:55, declination -5 degrees, 59 minutes, 31 seconds. Backing out for a prettier view. This is our 150x view, and this is something we were able to make it out from the very beginning at 60x at 20 arc seconds in size, primarily due to its roundish and aqua blue color. Here we have a globular cluster, NGC6760 in Aquila. Let's fill up the field a little bit. Magnitude 9.1, 2.4 arc minutes in size, magnitude 15.6 second stars, and on the second pass it's screwed up. You know, I might as well just go over to ASI image if we're going to have to keep dealing with all these distortions, but no, I want to finish it up. Anyway, it's a class 9, 24,000 light years distant, right ascension 191111, declination 010149. I'm going to pause it and give you another nice view. Okay, there's that second vision of NGC 6760 before everything starts to muck up. Here we're looking for NGC 6765, a planetary nebula in Lyra, magnitude 12.9, 38 arc seconds in size. Well, that's very strange right there. 7,600 light years distant, right ascension 191106 plus 30 degrees, 32 minutes, 44 seconds. We are getting that inevitable distortion that I have yet to fully diagnose out, but I would definitely, I don't want to attribute it to something I can't fix personally. I can't write the code for these people. I don't know why they shipped out a version, however, that wasn't able to do tracking any longer and stacking. Anyway, that's our view, 6765. The only thing that looks like a planet, the only weird thing is this striation right here. I'll have to look up online an image of it, 6765. All right, quickly, one of my favorite, most ghostly planetary nebula. Let's back it out a little bit, get a little more clarity on it. Oh, it's just perfect. An Aquila, magnitude 14, 75 by 55 arc seconds with a magnitude 18.1 central star, 4,100 light years distant. Let me pause this for a second and we'll reiterate the image. It's at 19 hours, 14 minutes, 36 seconds, declination -2 degrees, 42 minutes, 24 seconds. I am going to pause it once again and let's see if we can probe for that central star of magnitude 18.1. That would be a very nice catch. Okay, running up the magnification. There are hints of a brightening right about there. Now I could play with the histogram. Let's see what that does to it. That doesn't seem to bring it out any better. We are going to get the distortion shortly. Well, I wouldn't make any claims to seeing that star tonight, especially because we're not stacking. Oh well. It's enough for NGC 6772. I would call it the ghost planetary in Aquila. Oh, look at that. Sad, so sad. Okay, we're looking for this very planetary right here. NGC 6778 is also 6785. Do a little zoomage on it, take it up to 150x, and we already got distortion. Let me go ahead and reiterate. 6778 is magnitude 14.8 central star, overall magnitude 13.3, 19 by 13 arc seconds, right ascension 191824 with a declination of -1 degrees, 35 minutes, 47 seconds. Ain't much to see here if we have to put up with this continual inability to stack images, 10-second images. Okay, I've had to initiate a new protocol now. I have to stop right after a single stack. This is NGC 6800. There was quite a gap of studies visible because they were all too far north after the last planetary nebula. It's an open cluster in Vulpecula the Fox, 5 arc minutes in size, some 20 stars, magnitude 10 brightest. It's a class 3 too, so not particularly well distinguished from its background, 3,300 light years distant. Right ascension, 19 hours, 27 minutes, 7 seconds, with a declination of +25 degrees, 8 minutes, 24 seconds. I went out on the dumbbell last night. Let's go out on the crescent, even though things are going to get kind of messy. But you know what I'm going to do? I'm going to cheat this thing a little bit. I am going to put a 30-second exposure in. Let's see what happens when we do that. Okay, what you're seeing there is it actually did manage to nab the Crescent Nebula NGC6800, which will be part of tomorrow's series, in a 10-second exposure. I'm just wondering what it's going to do when it overlays the 60-second exposure. Saying, okay, we're going to have to reinitialize that. Hold on a second. Okay, I stopped the next stack. Let's see if it actually works. So stacked one, it ignored none, and the total exposure time is 30 seconds. We are looking at NGC6800. It will be our last view of the evening. I'll give you data on it tomorrow, but it's actually a study of mine that's always been of interest. I have seen this section vaguely through a 6-inch scope at the eyepiece. It's about 20 arc minutes across by 10. Probably got a 14.5 magnitude average brightness. There's lots of texture in it. There's lots of gaps. Most of it is radiative. Some of it is reflective. There's some reflective components through there, and you can see the radiative components there. And with that, I am going to say, what? Carpe Noctem.